morning, students. Today I will explain electric field. Electric field due to finite wire and semicircle. Okay, uniform charge distributed semicircular wire and electric field due to arc. Arc means any part of the circle on which the charge is distributed. Because of these three, briefly we will discuss first, later we will do some problems. Now, first one, let's suppose this is a finite wire. There is a charge uniformly distributed over it. Now I want to find the electrical field at a point to P. Right? Now select a perpendicular line which is at a distance A. Right? Now I am selecting a small segment, its length is let dl, which is at a distance L from this central line. Now this small element will be subtended here at the point P, such that here is the angle theta and this small segment making angle d theta. Therefore length we know, A we know, theta also we know. So that because of this element here, there is electrical field, a small electrical field D acting in this direction. Now the linear density of the wire is lambda, which also we know linear density is equal to charge per unit length. So when you are extending here, if this is theta, this is also theta. Now this electrical field has two components. Along this wire, that is DE cos theta, and perpendicular component is DE sin theta. Now every small segment perpendicular components will cancel. Suppose this side also, at the same side, opposite side, say this same element, electrical component of D sin theta cancels, but this element horizontal component again here added, so that the total electrical field perpendicular to the wire, we are adding, that is electrical field due to perpendicular is equal to DE cos theta. So what is DE? K dq cos theta by r square, means distance square from this element where we find the point P, that distance is, let it be r. Here not space not there, that's why I am mentioned here. This is the distance from this point to this point. So again here some geometry we have to know first from this triangle. Cos theta is equal to adjacent side by hypotenuse A by r. Therefore on squaring here, r square can be written as r square coming here, a square by cos square theta. Similarly, again tan theta, from tan theta can be written as L by A. L is equal to A tan theta. And differentiate both sides, A secant square theta into d theta. This value substitute here, then we will get the D, small electrical field which is perpendicular to the wire, equal to K constant. dq can be written as here lambda into dl, that also dq by dl. Therefore from this one, dq is equal to lambda into dl. That substitute here, into cos theta by r square. K constant, lambda constant. What is dl? Substitute here, a secant square theta d theta into cos theta divided by, what is r square? A square by cos square theta. cos square theta, secant square theta, a cancel, k lambda by a into cos theta d theta remaining, cos theta d theta. Suppose if we want total electrical field is equal to integration of this, remaining are constant. That's why what is the integration of cos theta d theta? K lambda by a sin theta from here. This upper end is subtended angle theta 1, lower end is subtended angle from the central line theta 2. Therefore we can write it this theta can be varies this from here, this side, from this point to this point, lower point to upper point. What is the variation of the angle here at the point P? Let down minus theta 1 up plus theta 2. Okay, that this is theta 1 and this is theta 2. Therefore we can write it k lambda by a. What is sin theta 2? Sin theta 2 minus of minus plus sin theta 1. Why? Because sin of minus theta 1 is equal to minus sin theta 1. Again here minus there, that's why minus into minus plus coming. So this is E perpendicular is equal to k lambda by a into sin theta 1 plus sin theta 2. Suppose if you want parallel component, right? So in this direction, what is the parallel component there? Sorry, here in this case d sin theta for every element cannot cancels. Why? Because okay, so this component will be remaining here. All these parallel components will add, all perpendicular components also here we can add in this case, so that here E parallel also same DE. Okay, remaining everything will be same. What is changes here? Instead of cos theta, sin theta changes. That's why k lambda by a, right? Integration of sin theta from theta minus theta 1 to plus theta 2 into d theta. Remaining everything will be same. K lambda by a. What is the integration of sin theta? Minus cos theta from minus theta 1 to plus theta 2. Therefore minus k lambda by a cos of theta 2, cos of theta 2, okay, minus, why? Because here cos of minus theta 1 is plus cos theta 1. That's why here we can write cos theta 2 minus cos theta 1. Okay, to eliminate this minus, when it is going inside, the remaining is k lambda by a cos theta 1 minus cos theta 2. This is the E perpendicular component. Okay, so for finite wire there are two components of the electrical field that are going to add. Parallel components of the electrical fields also all we have to add, and perpendicular components also all we have to add. Parallel means parallel to the wire, perpendicular to the wire. Okay, similarly the electrical field due to arc we will calculate. Using that any shape we will find. Then these formulas applied in solving some of the problems. Okay, now see, for example, here electric field due to uniform charged arc of radius r. Let this is the okay uniform charged wire, and its center will be somewhere here. This is the arc. Okay, radius is r. Therefore bisect this arc, and from this central bisecting line select a small segment DL element on this wire. This DL element is subtended here from this vertical wire. Let the angle is theta, and this small element subtended angle is d theta, and here because of this dl element, electrical field is acting in this direction de. Okay, so with this vertical, if this is theta, this is also theta, therefore this also will have the two components de cos theta and here de sin theta. But initially let this wire will be subtended, total angle is alpha, therefore this is alpha by 2, this also alpha by 2, total is alpha means okay, from the central line left part is alpha by 2, right part is also alpha by 2. Now but in this case, as this arc is symmetrical about this bisecting line, the this component of any element will be cancel each other, only we will add the de cos theta component. That's why what is total electrical field? Integration of de cos theta. From which angle to which angle? Let this side is minus alpha by 2, this is plus alpha by 2, or vice versa. That's why minus alpha by 2 to plus alpha by 2. Now what is de? K dq by what is the distance from this element to the point to where we are finding the electrical field? Capital R square into cos theta integration. K into what is dq? Lambda. This is also linear wire, that's why here also linear density lambda into dl into cos theta, okay, by r square. Okay, k into lambda into what is dl again? Dl is equal to r d theta, r d theta into cos theta divided by capital R square. One r cancel, k lambda by r constants, integration of cos theta, okay, d theta, d theta there. What integration of cos theta d theta? Sin theta, from minus alpha by 2 to alpha by 2. Apply this limits here. K lambda by r sin theta by sin alpha by 2, minus of minus plus here also, because sin of minus alpha by 2 is minus alpha by 2. That's why alpha sin alpha by 2 plus sin alpha by 2. How much? 2 sin alpha by 2. This is the electrical field due to any arc with uniform charge distribution. Okay, using this, now we will find electrical field of semicircular, circular wire or any shape, quarter circular any. Okay, or otherwise those also derivations no need in the objective point of view, even in the board also cannot asking. That's why for semicircular wire, semicircular wire, let what is the angle? Semicircular wire, what is the electrical field at the center of the semicircular wire, right? Let the uniform charge will be distributed here also. Linear density is lambda, radius is r. So directly apply here, no need to derive, no? That's why what is the electrical field? 2k lambda sin, what is the angle made by this particle? Okay, from this end to this end, from a end to what is the angle made by the a and b ends over this point? 180 degrees. Therefore theta means alpha means 180 degrees by 2 by r. Therefore 2k lambda by r into, so what is sin 90? Sin 90 means 1. That's it. This is the electrical field due to semicircular wire. Like this quarter circle means 45 degrees, so root 2 times coming. That's it. Like this, using this formula we can find the electrical field due to any shape of the body, quarter circular, semicircular, even circle also. Circle means theta how much? Theta 180 to 0 coming, means at the center of the circle electrical field is 0, right? Now we will solve one problem based on these concepts. They are asking the problem such that here, let a semicircular wire. There are some infinite wire. This is the one plane. Again, this is another plane. Okay. From this point O, let's suppose this is y-axis, this is x-axis, this is z-axis, right? Now a semi-infinite wire will be provided, placed such that here from A, and after this again a semicircular shape also there. This same wire will be like this. Okay, and again this wire will be having another semicircular shape. Okay, means one wire will be like this acting along the z-axis. This also one wire will be acting like this. Okay, there are two wires they coupled as shown in the figure, and over all this one there is a charge will be there. All will be charged wires. This also charged wire, but this is semi-infinite wire. This also semi-infinite wire. Let A, B, C. Okay, this is D. But without using all these letters to solving the problem is better. We are using all this becomes more complicated. That's why what is electrical field due to semi-infinite wire? Like in the previous case, we know let first wire. This is second part. This is third part. This is fourth part. Fourth wire means 4 segments there. What is the electrical field due to first segment? E1 is equal to, okay, what is the K lambda by A into for infinite for finite sin theta 1 plus sin theta 2. K lambda by A. What is the angle here? One angle is infinite means 90 degrees. Let this is the, okay, theta 1, this is theta 2. Theta 1 is 90 degrees, sin 90 means 1. Okay, plus what is sin other angle? Other angle is 0. That's why here 1 plus 0. So answer is K lambda by A, E1. But here, what is the direction? This electrical field will be, this wire will be in which plane there? YZ plane. This is XZ plane there. This wire is in XZ plane. That's why due to this segment, the electrical field is acting in this direction away from this point. Therefore, along positive x-axis, that is a perpendicular component is I cap, and another electrical field is parallel to the wire, away from this point. At this point we are calculating now, at this point away from this wire. That's why this is what Z means this is positive Z axis. Okay, this is negative Z axis means minus K cap. Find the E2. Similarly, electrical field due to semicircular wire, 2K lambda by radius is let to R. We are not mentioned R into in which direction electrical field acting at the center. Okay, that is downwards. Okay, downwards means along negative y-axis. Negative y-axis means minus J cap. Okay, for semicircular wire, only one of the component of the electrical field only acting, remaining components will cancels. That's why only 2K lambda by R into minus J cap. Similarly, what is the third electrical field due to this wire is in XY plane, right? Even though it is in XY plane, but due to this wire, okay, perpendicular to this plane acting downwards, not perpendicular, parallel to the plane and acting downwards. But this wire is in XZ plane, so this also perpendicular to Z axis, but again towards the center, opposite. This is positive Z axis, opposite negative Z axis. So that's why this also 2k lambda by r into minus k cap. Next, what is the E4? Electrical field due to this semi-infinite wire. This is infinite, so this is theta 1, theta 2. That's why this also theta 1, theta 2 take here. Okay. Or otherwise, this is theta 1. Why? Because this is theta 2. This is also take theta 2. Okay. Or theta 1. Anyhow, same use formula k lambda by r into, okay, sin theta 1. What is sin theta 1? 0 degrees means plus, what is sin theta 2? Sin theta 2 how much? 90 degrees, 1. That's why here no issue here, whatever it may be. So this also k lambda by r. But what is the direction here? What is the E1 direction mentioned? Similarly, E2 mentioned, E3 mentioned. What is E4? Right. E4 is again away from this point towards this point. Okay, away from this point and toward where? Why? Because here we are finding the. That's why this is positive x-axis. This is negative x-axis. That's why minus I cap. Again here, from this away from this point, this is the which component? Perpendicular component. What is the parallel component? Parallel component is parallel to the wire, but away from the wire. Away from the wire means this is positive z. Sorry, this is positive z axis. Okay, along the positive z axis, the electrical field is acting. That's why plus k cap. That's it. So by summing all this, we will get the total electrical field at point O. E0 is equal to E1 plus E2 plus E3 plus E4. But here by seeing here plus I k lambda by r, sorry, 2k k lambda by r, I minus k lambda by r, I minus k here, minus I plus k. That's why this both will cancels. Okay, only, but what is E2? 2k lambda by r minus j, 2k lambda by r minus k. That 2 only adding. Therefore 2k lambda by r, take minus common, j cap plus k cap. This is the total electrical field at a point O due to semicircular wire and two circular wires and another. So this is the procedure to calculate the electrical field of any shapes, right? See, for example, one more problem we will solve here. Based on this model, they are extending the questions. They are asking accelerations or velocities or whatever it may be. Let's suppose same problems. This is the plane. This is the xy plane. This is x-axis. This is y-axis. But this is xz plane. XZ plane. Same, this wire is in xz plane, semi-infinite wire. Due to the semi-infinite wire, we are finding the electrical field at point O. And again another semicircular arc. Due to semicircular arc, okay, at a point O, we are calculating the electrical field. And again due to another semi-infinite wire. Okay, this is a question, but they are asking some magnitude of the charge Q is kept at a center of this semicircular wire. If it is the Q kept there, then what is the acceleration of that charge? They are asking. Find the acceleration of the charge. Find the acceleration of a charge. So here, like in the previous case, electrical field due to this semi-infinite wire and due to this semi-infinite wire, minus I plus k, I minus k, minus I plus k, both cancels. This electrical field and this electrical field cancels. Only what is the net electrical field? Only due to single semicircular wire, that is already we know, that is 2k lambda by, let radius of this wire is r. This is the electrical field. What is the force acting? E into Q. In which direction? Okay, means toward the center. Due to this wire, toward the center means okay, along the negative y-axis. This is the force, but they are asking acceleration is equal to force by mass. Let the amount of the charge q and mass of the charge m given in the problem. Therefore, F by m is the answer. Therefore, what is the acceleration the charge will gain? 2k lambda by r into q into minus j cap. So, the into m. This is the answer. Or sometimes k means 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught means how much we will get? 2 ones are 2 twos are. Therefore, we will get lambda by 2 pi epsilon naught r into m into q. This is in the direction of along. Acceleration is the vector quantity. That's why that we have to represent like this. So like this, many problems we can solve based on this model, right?